All right. Let's go on. Then we come to now you can demonstrate energy. Okay. So the two which are here, this is positive, this is negative, attracting. So there's energy holding there. Okay, right? Different forms. Okay. Right. Okay. So when you break this one, you can use heat to break this one. Okay, heat can get in the form of energy to break this one and separate them. Then when they separate, you can meet another one. Let's say this person. Heat to break them. So just to break bonds. Okay, so heating to break bonds. Just a sketch. This. So I have this one here, heat, and heat, and that. Okay, so this is just demonstrating. So you can use your magnet to demonstrate. Let's demonstrate because they can't visualize. Okay, so they are attracting when you have no flow, it's not flow. If you are pulling them apart, it's difficult. So you need energy to separate. Okay, the same way the atoms, the ions are attracting. So it's difficult to break. When you need energy, So you are adding energy. This one you're adding energy. Okay, to separate them. When two can also come together. This is charge. This is negative. They are coming together. Okay, to form this. Okay. So here, when they form, they will give energy. Energy will be given away heat. Okay? Then the whole place will be having energy, right? So that is this demonstration. So the gas laws. Gas laws, you have the ball, then you can start pumping it. Okay? The pump connected to it. Then something like that. Okay, so we pump air will go in, go into this, and it will become very big. Okay, now what will happen if you try to push it? You can squeeze it. If you squeeze it, it will come to this point. As you squeeze it, the particles will be hot inside. Squeeze it, see, you increase the pressure. Pressure will go. You are reducing the volume. Somehow trying to reduce it. The pressure will go up. Okay, if you release it, then the pressure will go. Okay, the pressure will go. Okay. So you can also decide to sit on it. If you sit on it, the pressure will increase. If you get up, to open up, the pressure, will go down here. Okay, you can do that. You can use this one to demonstrate the football. Okay. Then use your pump. Right. To demonstrate, just to show something. Okay. So here, all that you are going to do is here is sketching. You are not going to use the actual thing. Okay. So salt, we can have our salt as well as we can have our salt like this. Okay. And you can have something like that. Acid. This. Okay. When they react, okay. Yes, you can demonstrate that maybe put something representing salt and acid, something representing base, okay? And they put together, see, wow, it has changed to salt. So it means acid and base react to form salt. So it's ACl, that's right, going into what? NaCl, that is the salt. That's H2O, that is water. So here, no water. When they come together, now we have together, then we have water inside. Okay, so there is no water, now we have water and salt. Okay, so right, you can even heat this one, and later if you heat, water is going to evaporate, it's going to go out. And something will start coming out, forming at the bottom. Okay? You are not supposed to use these two there, only salt. So you can put salt in water, concentrated one, and heat it, and it will evaporate, and then this you stop it, this is going to condense. If the cool, okay, if the cool is so much, of course you have it precipitate inside. Okay. So this is going to go down again. Guys, using precipitation. Okay. But you can draw it, you can draw to show precipitation, you can draw to show. You may not get it, you may not be able to demonstrate that, but you can draw it to show. And so just sketching that. So this is for that topic. So remember, we are not using that. We are not using that. This one is going to use that. So here we are looking at nuclear chemistry. So here we are going to look at the nucleus. So this is the nucleus. This is the nucleus. This is an atom. Okay, you can draw it. Just draw it. This electron. This electron. So the electrons, when you come in, that is chemical reaction. That's going to be a chemical reaction, simple one. Okay, and this that can also come together. So it will be a form of chemical reaction we call nuclear reaction. Because it's the nucleus. Okay, so this will come together. This will give a very huge energy like bomb. Okay, said in Japan it happened. Okay, during the second World War. Talk about that already. Okay, we call that the atomic bomb. Okay. Okay, so this is the electron. But when this and this are coming together, that's nuclear reaction. Okay, this will be just a simple chemical reaction. Sometimes no reaction, but just physical mixing. So this is mixing. This is just mixing. Okay. Reaction will be here, electron and electron. Okay, that's reaction. Here we can have only the neutrons coming together. So this is nuclear reaction. This is normal reaction. Okay, there's the normal reaction of the world. The two are all chemical reactions. Okay. We are not writing for this is the writing I'm doing is for you, the teacher, okay, the one demonstrating today. So here they are mixing, okay, here they are reacting, energy is coming in, and they are just mixing in a solution, okay, they are reacting, okay, so mixing in a solution. So when they mix, it depends. You can cause water to evaporate and some will precipitate, okay, some will not, okay. So you can have sodium chloride. Aqueous. Okay, this is the solid. So this is the precipitate. This is the solution. Okay. Right. So this demonstration. This I'm writing for you to see. Right. So this is what is happening. Now let's look at chemical reactions. Okay, the chemical reactions. So here is an electron coming. This the nucleus. Okay. Going to react. Okay, this is reaction. If they come that fast, they can be fast. It can be slow. It can be fast and slow. Okay, and that is rate. Okay, so this can come together very fast and form something like that. This one can come slowly before they come slowly. Before they finally come, so this is so slow. This one is slow. This one is just once. This is fast. Okay? So just demonstration of rate of reaction. This can just be. And the redox reaction. So this one is the element I have. Just two electrons. Okay, come like that. So there's this one. Come okay. There's two. Okay. So it can be here or there. It can be here or there. So these elements will help. They will react in redox reaction. Okay. I can use this one to react, I can use this one to react. they usually will come in what you call redox reaction. Okay, so just demonstrate it. You take one here, and then just to create a picture of somebody can, the same thing can be, so this A can be A plus, can be A2 plus. For example, is iron, and 2 plus, iron, 3 plus. Okay? So the one element can exist in this form, that part of that element can go through redox reaction. Okay? So we can have reduction here, losing electrons, okay? Electrons are going away. And then oxidation. Yeah, you see? Sorry. Here, when they say it well, reduction. You are adding electrons to something. Okay, adding. So plus, okay, plus let's say X. You are reducing it. Okay, add electrons. And then oxidation. Here, you have X. X, then you are taking electrons away from it. Okay, taking electrons away from it. Okay, that's the one to see. Okay. But this is important. This may not be necessary. This is important. Just show something like this. So you can do another one with maybe 3 electrons there. To lose it 1, to come plus 1, you have 2. To lose it 2, 2. To lose it, come plus 3. You can use that to demonstrate. Let's play around with these sketches. So the sketches are for the lower primary. As of preschool, you cannot get that to do. Right. Now let's talk about our petrol. Okay, so we have our car here. So go to the tenants, go to the petrol station, pumping petrol into it. So the tank is here, pump petrol. This petrol has a lot of carbon, okay? Carbon, a lot of carbon, a lot of carbon, carbon. So you say anything with more carbon, we are saying it is organic, okay? It's organic, okay? Organic compound. A lot of this, so you have petroleum, a lot of carbon in it. This one, when you break it, you get carbon, another carbon, energy comes, okay? Energy that the car to move, okay? So that's our petrol going into the car, so that the car gets energy, move faster, right? So that is, and this one is carbon, so say okay? Those with no carbon, there will be no carbon, it will be inorganic. Okay? Going to the right. So these ones have their reaction, they will have their reaction, different reactions, okay? So let's look at the food, the nutrients that we have. Carbohydrates. Sugar is coming together. Okay? Again, it can be glucose. Another glucose. Okay? Sometimes another one we call fructose. Fructose can be there. Or maybe this one is another one we call galactose. It's in milk. This one is not galactose. Then fructose. The fruits that we eat, the sugar in it, okay? And it's part of what we call sucrose, okay? Fructose and glucose. Sucrose, okay? We have maltose. The two together. One is maltose. So this will be found in the lactose, okay? That will be the lactose. Glucose, okay? Glucose, lactose, the two. Okay? So you can look at it this way, this A and B. You can have protein, protein. Protein. These are protein. any of them. 20 of them coming together. So when it is a little short, you can have peptide. You have polypeptide. So for your polypeptide, for your spelling, okay, then you come to your protein. Okay, come to this peptide. Okay, for this coming together, come your polypeptide. Okay, then a lot of them coming together with the protein. So protein. Then and the third one, fat. Fat and oil. Okay. So fat and oil, we have the coming together. Okay, what to do? So we have what's called fatty acid. Okay. Fatty acid. What to them coming together? Okay, sometimes they are in complex with another one called acid. Okay, and then they need phosphate from there. So fat, oil, okay, they are called lipids. Okay, lipids. Or lipids. Right. So this is the fat and oil, the cooking oil that we have also. So this, so I said sketch them, they are doing together. So this is the big one. We can break it down. When we take it into our body, what do we start breaking them down, breaking them down, breaking them down. And the body will use this one for energy. For energy. We use this one to give us muscle. Okay? Use this one for energy. Okay? And the fat in our skin. The fat under our skin. Okay? And of course, once we are eating, anytime we eat, we have water there. We have water. Then we have another one called small one that we need. Minerals. Okay? Minerals are there. The sodium, our iron, all there. Then we have what we call the vitamins. Okay? The vitamins are also there. Vitamin A, vitamin B, C, D, vitamin K, all there. For small, these ones, we need them very, very small. We need the minerals and the vitamins in small quantities. Okay? As for what that is, we should have a lot in our body. A lot. Okay? Right. So, but of course, sketch is important. Get them to sketch.